Since it's MIG Monday and I'm in training for my new job at weld.com, I think I'll just go ahead and make a video for you right now. So my little blue friend here is a Millermatic 212. It's an older model, but yeah, it works really well for me because it's dual MIG. So originally it has, like I run like 12-pound 706 wire through that. 80-20 on my MIG, and run straight steel. But at the same time, I have my spool gun set up where I can MIG aluminum and run a secondary bottle of gas, which is straight argon, to MIG aluminum. This side over here is my 75-25 for MIG steel. This is my argon tank, which you can see I have a splitter on it. The flow meter goes to my TIG machine, and the regular gas meter goes down into my Millermatic. One bottle of gas, I'm able to run two different machines because of the T-valve. Anytime you're welding aluminum, it requires 100% argon. Two things when welding aluminum: cleanliness of your material and gas coverage. You get those two things figured out, you will be an aluminum welder, no problem. MIG, guns and barrels and tips all affect gas coverage. Okay, I run about 35 CFH on my gas coverage. Somewhere in between 25 and 40 is where you're going to be, depending on heat, depending on how much power you're running, will depend on how much CFH you're running as well. I'm usually welding 1/8 inch or less materials, so that 25 to 35 works well for me. Now, wire size and tip size. Oddly enough, you need to run 10 thousandths over on your MIG tips. I run 0.35 wire, and I recommend anybody who does so run 0.45 tips. However, on this beautiful piece of engineering, Miller decided not to make 0.45 tips, so I have to run 0.35 tips. If you cannot get tips that are 10 thousandths over on wire size, extend your stick out. Now, on typical steel MIG, you would run about 1/2 to 5/8 of an inch. Really close, right? But steel wire doesn't expand. Aluminum wire does. So if you were to attempt to weld like this, your wire is actually going to get stuck in the tip. By extending that lead out to about 3/4 of an inch, you're going to minimize your swelling and minimize the sticking of that tip, and it's probably going to run a lot smoother. Now, to set the gun up, we're going to take the wrapper off our wire and pull a section of wire out straight. Before I load the drum into the gun, I'm going to thread it through the cone and pull the trigger. If your gun's set up right, it should grab the tip of the wire, and you'll be able to go ahead and load the drum and see that the tip of the wire is already in the barrel itself. Then just hold the gun down until the wire comes out the end, and you're good to go. So I'm going to do something maybe a little different than what you're used to. You can see I've got a piece of aluminum set here, and I'm going to run a couple beads. However, I don't want you to see what I'm doing. I want you to listen to what I'm doing. The weld settings on my machine are going to be completely different from the weld settings on your machine. Pull the menu down, find the wire speed and power settings, and set your gun up for the material thickness that you're welding. The most important thing to listen to what you're doing and listen to the weld profile. It has its own sound. It will let you know if it's digging hard, if there's too much wire, or if there's not enough wire. So, without further ado, let's burn some wire. You hear that? Kind of sounds like sizzling bacon, right? That air. That's what I want. That little step, or that little lower sound, is actually me stepping forward. The crackle pop is actually wire filling up around the puddle and making a weld profile. So here's what my little weld looks like. All right, nothing fancy, But you see, there is a noticeable step. As I'm welding, I'm holding for a half a second, I step forward, and I hold for half a second, and I step forward. Each step is not leaving this round part of the weld pool. I'm actually stepping right to the leading edge of it, and then I'm letting that pool work out in front of the gun, and then I step forward again. Make sense? Now let's turn the wire speed down, and I want you to listen to what it sounds like. This is very important. See the difference? So that slower feed, that plip, 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 sounds like a Harley that's running on 86 octane. All right. I was going slower, physically slower when I'm moving, and you can see over here, this one, that weld profile is actually taller because there's less heat going into the weld itself. If I roll it over, our first one, she's a little hot. Our first one had a good weld profile and a small blister on this 100 thousandths material. But over here, even though the metal is already hot, our second bead didn't blister the material as much because less metal was being drove into the plate. Now let's take it the exact opposite. On my gun here, I was at a 3, and I dropped down to a 2.5. Now let's take it up to 3.5. I tell you what, let's go extreme. Let's go to 4. I'm going to take that 4 feed rate, and I'm going to weld again. This time I want you to listen to what it sounds like. Not only that, I'm going to turn around here because my gun's probably going to do some funny stuff. Okay, she's a little hot. Now, that feed rate wasn't as bad as I thought it would be, but, and I'm not going to touch this right now, but I want you to look at it. See how smooth that is? And it was so fast, I'm not even able to push forward. Weld profile isn't terrible, but that is hot, hot, hot. Grab my glove here and try to flip it over. Yeah, man. That is some really bad blisters. So, by listening to what's going on with my weld pool, I want a slow, not slow, but a moderate, steady cooking of bacon. And the only time that it should not sound like cooking bacon is when I'm into my step. Every time I motion forward or motion a little bit of weave into my pattern, that bacon should kind of change just a little bit. If it is blowing hot and it almost sounds like a spray weld where it's going like that last one was, I've got a little bit too much feed rate. Let's get down here and do one more weld profile, and I got my machine or my feed rate set back to how I like it. So I'm just going to get down here and we're going to run one more bead and show you what it should look like and what it should sound like. I like that a lot. That sounds pretty good. Now, I will say that my stepping from this position is a little excessive. So, here's one we did off camera. And make sure I had my settings just right. And here's the one that we just did. Now, the part is pretty hot. But you can see I've got, my steps are a little bit long. At the beginning here, we still got a little bit of a hump. That's a cold start, all right? But you wait on that cold start just a little bit and then start moving. And then down here on the end, we've got a bit of a crater. Once I come to the end, I raise my gun up and push the puddle back to terminate. That keeps my crater from being way out here on the end, and it begins to fill the crater right there and makes a nice little divot, which I probably could have waited just a little bit longer for that divot to fill. All in all, it's a good weld.